A little tricky. Let's just go through some facts we need to know. They're a little obscure in order to answer this question correctly. But the first thing is that f and g are inverse functions, and they're differentiable for all x. Now, in order for a function f or g to even have an inverse, it needs to be what's called one-to-one. It can't repeat any of its values. So, like, for example, right, if I look at the graphs of these things, right, if let's say I have some function f and it looks like this function cannot have an inverse. Because if you look, right, I don't know, some upside down parabola, whatever, it can't have an inverse because this value at a is the same value. They're both equal to some value here, I don't know, m, whatever. F of a and f of b both equal m. And when that's the case, it's not one-to-one. It fails what's called the horizontal line test, if you will, and it can't have an inverse. Now, what this implies is that if it is gonna be, right, one-to-one, or if this occurs, right, or something like this, right, if you notice, if you look at this function, right, it passes the horizontal line test, right? Every single horizontal line only intersects your graph once. That's the horizontal line test. You see this one, when I drew my horizontal line, it intersected the curve twice. But if I look at this one, every single line, and if you look at this function f, it's always increasing. And it must be the case that if your function has an inverse, it must be that it's always either increasing or decreasing. Because if it goes from increasing to decreasing, then it's guaranteed to fail the horizontal line test. So that's the key here, right? If a function goes from increasing to decreasing, then it must fail horizontal line test. And thus, and therefore, if you will, and therefore cannot have inverse. So here in this problem, we're given that g prime of -2 equals -4. What that means is since g has an inverse, it must mean that g is decreasing everywhere. The reason for that is because the derivative tells you whether the function is increasing or decreasing by whether it's positive or negative. So since it's the case that g prime, or the derivative, right, is negative, that means g is decreasing at -2. But since g has an inverse function, it must mean that g is decreasing everywhere. Now we use another fact. So now we say, okay, and I always write it out. F of g of x, I never remember it. You guys can always derive it. F of g of x is equal to x. So if this is by definition of inverse, right? F undoes what g does, so we just get out this inner value x. Now if I differentiate this with on both sides by chain rule, it's the derivative of f with g plugged in times g prime is equal to the derivative of x is just 1. And in this case, I'd be getting a formula for g prime, so I should do it in the other way around, which is the same procedure, g of f of x, because I want to get a formula for, oh no, this is fine, yeah. I want to get a formula for f of x. So, okay, so let's start over. Same thing. This you would have gotten that g prime of x is equal to 1 over f prime of g of x, but the roles of f and g are interchangeable. So like here, I'll do it again, right, with this one. And I differentiate g prime f of x times f prime of x equals 1. And now I get a formula for f prime of x as g prime of f of x is equal to f prime of x. And basically now we look at this formula and we should know, look, g prime was negative for some value. That means that g was decreasing and is always decreasing. Why is it always decreasing? Because g has an inverse. So since it's the case that g is always decreasing, right, that means that this value right here is always negative, which means that f prime of x, or this, is always decreasing. And that forces this value is not less than it's equal to, but this value is always less than 0. And that implies that this cannot give you a positive value. So this one must be false. If you go through it, look, f prime of 3, you could use this formula and you could actually verify that this one it must be true. So this one must be false. So this one, let's make it clear. This one must be false because of the logic that I just gave you, but I'll do it again when I come back to it. If I actually use this formula for this one actually must be true, and then this one could be true. So this one, it could be true, it could be false, but it's asking which one must be false. So it could be true, it could be false, this last one, if you go into the details. But let's conclude for sure that one is false again. So I'm going to run through the logic again. So basically, f and g are inverse functions that are differentiable for all x. Okay, if it's differentiable, then it's continuous. Okay, so it's continuous for all x. So these are continuous functions. Now, if you look, right, the only way a continuous function, has an inverse is if it's always either increasing or decreasing. Otherwise, it's going to fail the horizontal line test. Because if it goes from increasing to decreasing at any point, right, it's decreasing, decreasing, decreasing. If I begin to increase at any point, right, boom, it will fail the horizontal line test. If it's decreasing, if it's increasing, and then boom, it begins to decrease, it will fail the horizontal line test. And if it fails the horizontal line test, then it cannot have an inverse. This forces f and g to either always be increasing. So f must either always be increasing or always decreasing. And g must always be increasing or always decreasing. Now, with that being true, it gives you some value for the derivative of g, and it's a negative value. That means that g is decreasing at -2. But we just said that if g is decreasing, right, at some point, then it must be decreasing always. So this statement essentially says, this statement with the fact that g has an inverse is that g is always decreasing. And since g is always decreasing, its derivative is always negative. And then I get this formula here for the derivative of f. And essentially, if g is always negative, this value down here is always negative, making f negative, f prime, sorry. Okay? So the derivative of f is negative. So then that means that f must always be decreasing, or that the derivative of f must always be negative. So you know this one must be false. Because here it's saying that the derivative is positive 1/4.